Well, I want to welcome you to part two of our little briefing on what is truth. And in this part, we're going to examine our boundaries further. We're going to explore a little bit about the time domain. And we're going to talk a little about, again, about entropy as the arrow of the time domain. Because the time domain is a very strange dimension. It can only go in one direction, generally. And entropy is the arrow of it. And we'll talk a little bit about negentropy. That's the opposite of entropy. It's a synonym for information of life. And we'll talk a little bit about extraterrestrial sources. We'll talk about qualifying your sources of information and testing your hypotheses a little bit. And so let's start by talking about the nature of time. And I'm going to start by asking you to remember what you learned in school about trigonometry. You may recall that in school we learned that a triangle, if we add up the angles in each of the three corners of a triangle, it adds up to 180 degrees. And that was true of any triangle that we encountered. And so suppose a couple of us went out to a large field with a transit, laid out a large triangle, and we added up the three angles of the three corners, and it added up to more than 180 degrees. What have we encountered? Turns out that what we have encountered is the curvature of the earth. The little rule that we all learned in school about the triangles having only 180 degrees was true of a plane geometry. That is, it was only true of a universe of two dimensions. That's why they called it plane geometry or plane trigonometry. And if we violate that rule or encounter a violation of that rule, it's a hint that maybe we've encountered an additional dimension. If you take a course in navigation, that will include a course in spherical trigonometry where you can have 90 degrees in each of the corners. It's very different. So if you encounter a triangle with more than 180 degrees in the sum of the angles, you know that you're in a convex surface. If you have less than 180 degrees, it turns out you probably encountered a hyperbolic paraboloid, which I don't think is a concern to most of us. We'll move on, okay? This was the kind of insight that led to Einstein to his revolutionary theory of special relativity in 1905, where he discovered that length, mass, and velocity in time are relative to the velocity of the observers. But then he generalized that in 1915 to what we call the generalized theory of relativity, in which we know that there's no distinction between time and space. He realized that space is a four-dimensional environment, not three as we visualize it. That time is just another dimension to our spatial environment. And this four-dimensional continuum has been confirmed at least by 14 different ways to 19 decimals. It's a very useful, predictive technology that's available to us today. But to get this idea across, its implications for you and me, I want to talk about gravitational time dilation. There are identical atomic clocks that are located at the National Institute of Standards and Technology in Boulder, Colorado. And one that's identical to it is also installed at the Royal Observatory in Greenwich, England. These are fairly complex devices. They're very, very incredibly precise clocks. And they are both accurate to better than 1 second in a million years. They're very, very precise clocks, both at Greenwich and at Boulder. And the reason I remember, and this discovery, we're positioned in the galaxy, positioned for total eclipses, positioned with the visible spectrum, and it goes on, dozens of these things. This implies more than accident. This implies teleology, a purpose. Not only are we designed, it indicates there was a purpose in the design. And there's a recent book out, The Privileged Planet, by Gonzalez and Richards, that I encourage you to get. There's also an astonishing video out by them which uses computer graphics to demonstrate all these things. It's absolutely breathtaking. I encourage you to check into it. But I'd like to talk a little further about the constants of the universe in another way. It turns out that many of these constants that have dimensions are very, very sensitive. But there's two constants in the universe that are dimensionless. One that you're probably very familiar with, and one that you're probably not familiar with unless you've been active in very advanced engineering or math, what have you. The first one is pi. We all learned that in school, that the relationship between a circumference and a diameter is 3.14159, a bunch of other numbers. We call that pi. It's the ratio of the diameter to the circumference. That turns out to be true no matter what units you're measuring, whether it's metric or English or what you name it. That relationship is intrinsic to the relationship between the diameter and a circle. There's another one called a natural logarithm, log to the base e, and I'll talk about that in a minute. It's kind of interesting to discover there are two key verses in the Bible about creation. Obviously, Genesis 1:1, in the beginning, God created the heaven and the earth. And John 1:1, in the beginning was the Word was with God, the Word was God, and so forth. All things were made by him, without him was not anything made that was made. So these are the two key passages in the entire Bible on creation. Well, it's been called to my attention that if you take the first verse of the Bible in the Hebrew, and Hebrew letters and Greek letters have the distinctive that they have numerical values, each one of them. And if you take the Hebrew here, Bereshit, bara, Elohim, and so forth, you take the number of letters times the product of letters, and you divide that by the number of words times the product of the words, you end up, interesting enough, with pi to 4 decimal places, 3.14116, 4 decimal places. You say, well, gee, that's kind of a strange coincidence, but it is what it is. It turns out John Napier, who was a mathematician in the 16th, 17th century, activist for the Reformation and the Protestant affairs in Scotland, turns out, he was the inventor of what we know today as logarithms. The natural and Napierian logarithms, or logs to the base e, or sometimes called natural logarithms. He also established the use of a decimal point in fractions. But the number e shows up in advanced math. Unless you've been in calculus or advanced math, you probably never run into it. It is a very unique kind of number. It has a limiting value of about 2.7183, or 28 on. It forms the base of the natural logarithms. It appears as an exponential function. It's the only function having a rate of growth equal to its own size. In the language of calculus, it's the only function having a derivative equal to itself. And therefore, it's a fundamental function for certain equations of growth and other processes. So they show up in wave mechanics. It shows up in electrical theory, advanced math, distribution of prime numbers. It shows up in the strangest places. And if you've been in advanced math, you've come across E as frequently as a geometry student comes across pi, if you will. Well, if you take the first, the key verse of creation in the New Testament, in the beginning was the Word was with God, the Word was God, John 1:1. You take that in the Greek, and there again do the same thing we did before. The number of letters times the product of letters divided by the number of words times the product of words. Guess what? It comes to E, to 4 decimal places. Now, I don't know what you're going to do with that piece of information. It doesn't prove anything, but it certainly gets our attention. You see, the rabbis have a very strange view about the Torah. They not only believe God created the universe, they believe the Torah contains the templates by which he did it. Rather interesting point of view. But there are recent articles in some of the journals because they're discovering that the things that they thought were constant aren't. The speed of light was regarded as a constant. I was taken to dinner by a number of my old friends that were upset because I was publishing in our news journal over a decade ago articles by Barry Setterfield, arguing that the speed of light is not a constant, that it's been slowing down. And my well-meaning Christian physicist friends said, Chuck, you're going down the wrong path. Everybody knows that there's nothing more sacred than the constancy of the speed of light. Undergirds most of physics. I was deaf to that, was polite, but deaf to that. And it turns out that within the last couple of years, there's a number of articles in reputable journals that are discovering, my goodness, the speed of light is not a constant. And none of them had the character or the integrity to make reference to Barry Setterfield, who've been saying that for several decades. But nevertheless, they're now waking up to the fact that the constants of the universe are not constant. And there's studies going on to try to concern themselves with that. In Scientific American in June 2005, I love this phrase, they believe that our reality, our three-dimensional reality, is but a shadow of a larger reality. That's something the Bible has been saying all along. And we read that earlier. So we're going to go to the next part 2 of this What is Truth excursion. In examining our boundaries, we're going to talk specifically about the time domain because it's going to be very useful to do so. We'll talk about entropy as the arrow of dimensionality to the time domain. We'll talk about negentropy being essential for life. We'll talk about extraterrestrial sources of information that we can draw upon and how we qualify sources of information and how we test hypotheses. So join me for part 2.